Hi, this is David Voss, CCIE 11372, and in this video we're going to cover the remaining WAN technologies or considerations that you need to know for your CCDA exam. We're going to cover remote access design, then VPNs, wide area network backups, and then finally enterprise branch module design. Let's start with remote access design. When designing the remote access block, you must ensure that the network users have transparent access to the network from wherever they are, just as they are connected to the actual network. The users must be able to reach the resources they are authorized to use as they would from the enterprise campus. In order to provide these services, the connection requirements must be analyzed carefully in order to ensure they are fulfilled. Typical requirements include VoIP support, VPN support, high volume traffic or low volume traffic, permanent connection, is it needed or not, and the type of flows. Now, VPN concentrators have often been used to accept these external sessions, but Cisco's multifunction ASA platform is now the standard platform for providing both security and VPN services to the RAS block. The RAS block is normally comprised of firewalls and systems that can provide VPN and security solutions all in one, or they can be broken out, such as VPN concentrators, dial-up networking services, and of course you still want to have your security, so IDS and IPS solutions to actively monitor any unwanted traffic or activity. So let's get more granular and talk about VPN network design. Even though the VPN concept involves security most of the time, unsecured VPNs exist. A very basic example of this would be frame relay. VPN troubleshooting is difficult to manage because of the lack of visibility into the provider infrastructure. The service provider is usually seen as a cloud that aggregates all the network locations connections. So when performing VPN troubleshooting, you should first take a look at the problem on your end and make sure it does not reside on your devices. And then, if you are sure, or as sure as you can be, reach out to your ISP. Types of VPN technologies include the following: site-to-site VPNs. These are used to connect different locations over a public infrastructure. Now, when using peer-to-peer infrastructure, you can communicate seamlessly between sites without worrying about IP addressing overlap. Remote access VPNs, such as in the older days, VPDN, Virtual Private Dial-Up Network, although you may still see that here and there. Or surely you're aware of VPN software that you can run on your laptop nowadays to connect into your corporate network. And then there's extranet VPNs to connect to business partners or customer networks. With VPNs, traffic is often tunneled in order to send it over an infrastructure. Now, the tunneling methodology for Layer 3 is called GRE, or Generic Routing Encapsulation. GRE allows traffic to tunnel, but it does not provide security. So let's talk about GRE and then also the options you can use to provide security over GRE.
GRE was developed as a tunneling methodology which can carry Layer 3 protocols over an IP network. In essence, GRE creates a private point-to-point connection like a VPN, except GRE does not provide secure communications, but we'll deal with that a little bit later. GRE works by encapsulating payload traffic inside an IP packet. GRE tunnel endpoints send payloads through tunnels by routing encapsulated packets through IP networks. Here's what makes it work. The IP routers along the way do not look at the payload. They look only at the outer IP packet as they forward it towards the GRE tunnel endpoint. And upon reaching the tunnel endpoint, GRE encapsulation is removed and the payload is forwarded along to its ultimate destination. Now, this is obviously very useful since a GRE tunnel can encapsulate almost any type of data you want to send out a physical router interface. So let's just walk through an example of GRE tunneling. Here you have a cloud, and let's say you have two routers, and they communicate over a provider network. So there are multiple hops over this network, and you need to tunnel traffic that the provider does not allow. The provider does not allow certain traffic over their network. So what you do is you create two tunnel interfaces, one on router 1 and one on router 2. And these are your endpoints for your GRE tunnel. Now over this GRE tunnel, you can send whatever you want over it because it has an IP header. The provider provides support for IP, but you can send whatever you want over this tunnel by encapsulating it in an IP header. And you are adhering to their standards, but you're also able to send traffic that you need to send over your tunnel, even if it's not permitted by the provider on a normal basis. GRE gives you that flexibility. When you hear the word encapsulate, now you may think of security, but GRE by itself does not provide any security for the data it transmits. So again, let's take another look at GRE tunneling from a secure perspective. We have two routers, and we're going to create a GRE tunnel between both of them. The traffic that is traversing the provider is encapsulated, but it's still not secure. It could be viewed if somebody wanted to view it. It's still in the open. So you could run IPsec and encrypt the data on, let's say, router 1. And as it's sent over to router 2, it stays encrypted over the provider network, and then router 2 would unencrypt that data and then send it. So again, from router 2 to router 1 would work as well. Again, the encryption is on the routers on our end, so anytime it traverses the provider, that data is secure. So IPsec and GRE often play hand in hand. The limitation of IPsec is that it can only protect unicast IP packets. So this causes issues for routing protocols that use IP multicasts. GRE allows you to get around this problem because a GRE tunnel can encapsulate IP multicast packets. So the resulting GRE packet is an IP unicast packet, but which can then be protected by an IPsec tunnel.
Next, let's talk about WAN backup design. Now, WAN connectivity can achieve backup through the following approaches. Dial-up backup, activated when a primary link fails, used to be very popular. Due to costs and bandwidth requirements, it's just simply not as popular today. Secondary WAN link, which is used for backup and or load balancing. This tends to be more popular. Or a shadow VPN, and this is used when the ISP establishes a second PVC or permanent virtual circuit, but the user is only charged for its usage. So this can be very useful when the main PVC fails or in situations where more bandwidth is needed. Finally, let's talk about the enterprise branch module. Branch modules are sized based on the number of users it needs to accommodate. For example, the enterprise teleworker, which is generally one user, single tier, tens of users, dual tier, hundreds of users, and multi-tier, thousands of users. As the number of users in the branch modules grows, additional layers might be needed. The internet block generally serves as the gateway for your internal users to the internet. If they want to browse, perform file transfers, or stream audio or video presentations, their flows would go in and out of this block. Now, notice how the internal traffic from your users is not using the same block as those who are coming in from the internet. This ensures that no external users are trying to hijack internal flows. That being said, oftentimes the internal and e-commerce blocks can share the same internet pipe. But if you prefer not to do that, you can use what is called a dual homes connection to two separate internet service providers to make sure that traffic is segmented. Now, if one internet service provider did fail, you could then allow all traffic over the same circuit as a fail-safe. The internet block is comprised of firewalls, routers, HTTP servers, SMTP servers, FTP servers, and DNS servers, to name a few. So here's what you've learned. You've learned about the remaining items you need to know for wide area network considerations and technologies for your CCDA exam. Some of it is granular, and some of it we stayed high level, but we definitely covered it to the level you will need to know for your CCDA exam. If you know what's in this video, you should do very well. Good luck in your studies.